detail on how to take values from each codebook. But as of now, I will just tell you what codebook is to be used for what member or element. So there are the codebooks are for three types. So codebooks, it's based on loads and load combination. It's given for three types: load combinations, for RCC members and elements, and for steel. So codebooks are divided in these three categories, and we will see one by one. For first, we will take loads and load combinations. For the first one is loads and load combination. In that, the first comes is dead load. For dead load, we use IS 875 part 1. I'm sorry, IS 875 part 1. Show you. So there are many code books. I think I have sent you those code books already. I'll be attaching it again today. So all the code books are available in the folder. This is IS 875 part 1. In this you can see, in this you will be given unit weight for all the materials, even for architecture materials like mortar. So this is you can see that there are unit weights everywhere. In this case you can see that cement concrete, or what is the unit weight for reinforced as well as pre-stressed. So based on the design and analysis of the required member, if it's a reinforced concrete, we'll be using that particular unit weight given in this code book. Everything should be taken from the code books, the standard values. So similar to this, architecture materials are also given. In this case, you can see cement, mortar, and there are many other values. This is just for example. You can even see regarding pipes actually. So one by one, when we get calculation requirement based on this, we'll be using this particular unit weight. This is what IS 875 part 1 provides. I have written it. So in this you will be given unit weight. We'll write down the basic definition. Unit weight for all materials will be given. Unit weight for all materials will be given. Materials including architecture. There's no space here. Natural materials will be given. Next comes for live load. This is mainly for dead load, IS 875 part 1. For live load, there's another code book. It is IS 875 part 2. IS 875 part 2. In this, live load will be given building wise as well as room wise. I will write it down and then show you. Building wise, as well as room wise, like dining, kitchen, hall. Those are room wise. And building wise means educational, hospitals, hotels. All that will be coming under building wise categories. You can see 875 part 2. Live loads are also known as imposed loads. This means nothing but live loads. This was the introduction. You can see that it has residential building. In residential building, it also include houses, hotels, dormitories, and
One minute, madam.
yeah.
Can you please zoom that? It is not so
Yeah,
clear.
yeah, it's not okay.
Little bit you can zoom it.
Yeah, just a second. This is not the Adobe which I actually thought of opening. Yeah, this is okay.
Yes,
Madam,
madam.
this is okay.
Yes.
Okay.
Okay, madam.
So these are the types of rooms which is given here. You can see that this is educational building, and in this also classrooms, offices, kitchens, everything is separate. So there is building wise load as well as the types of rooms in each building. This is how the loads are given in IS 875 part 2. When we do exercises or when we are doing analysis for a particular type of building, we will know what value to use. It will be given in the requirements itself. Next comes wind load. Wind load. This IS 875 part 3. The 2015 one is the latest edition or revised edition. So in this case, you can see that there is, I will show you just a second, part 3, 2015. In this, you can find wind map, how to calculate wind speed or pressure calculation. All this comes, this is not the starting actually, I think this is the beginning of the code. And after the basics, yeah, this is a wind map. It shows the basic speed. This will be useful in the calculation. Right now it's just for your reference. And this will also help us in calculating pressure required, turbulence intensity, and load on individual members. Yeah, all this will be studying in detail. Yeah, this is the pressure coefficients for walls. All these pressure coefficients will be used in our manual calculation and even in softwares when required. So this is how IS 875 part 3 is used for wind load. Next comes snow load. Snow load is IS 875 part 4. In this, you can see we'll be seeing calculating area and volume of. It will be given area and volume of different roofs and pressure, or due to snow, we'll be calculating based on that. IS 875 part 4. There are many technical terms in this. Yeah, the types of roofs, different types of roof, and how to calculate for each roof, what coefficients to be taken. All this will be considered while we are doing manual calculation. You might not understand all this now, but we'll be using it later, and that time everything will be explained to you clearly. Since there are various types of constructions, the snow load accumulated in each type of building is completely different. So the common buildings will be given in the code book, and we'll be using those values. So that is IS 875 part 4, and this comes seismic. The fifth one is, just a second. Yeah, seismic load or earthquake load. This is IS 1893. This is complete different code number. 1893. Seismic load or earthquake load. You can call it whatever you want. This IS 1893. I'll just open that. IS, yeah, this one. In this, different seismic zones will be given actually. Each zone, and according to the zone, we'll be having to take the values. Where exactly? Just a second. Yeah, like this, you can see there are different seismic zones and different types of soil. For different types of soils and different types of zone, what values to be considered for pressure calculation, how to calculate for irregular buildings, because regular buildings is completely, what if the building shape is completely different. Nowadays we see the latest architecture, it involves various shapes and sizes and designing. So while we do that, we have to consider a complete different kind of seismic pressure, and only according to that we can do. Especially in Dubai and all, you can see the buildings are all of different design, and at the same time they are all very huge tall structures. So they would have considered the seismic activity completely. The design would have been completely different, because they definitely have to consider both wind load and seismic load, even if there's no snow load. So we will be seeing for irregular buildings, we'll be seeing for base shear load distribution. Yeah, you can see in this, we can see there are seismic zones marked. So depending on the place of building analysis, construction, design, we'll be doing pressure calculation due to earthquake activity. This map is very useful while we consider that. Q load. In this, mainly seismic zones will be given. Seismic zones for irregular buildings. Etc. We'll be using this code book. The sixth one is for special loads. Sixth one is special loads. Special load is IS 875, part 5. Special loads are nothing but accidental loads, or when there's an explosion. I'll write it down here, accidental loads. Which doesn't fall under any other category when there is a sudden influence of some other load, which is not common, mainly due to, like I said, explosions. Or even load combinations comes under this code book. Load combinations mean dead load plus live load, dead load plus wind load and live load, like that, different combinations comes under this code book, that is also here. Yes. Yeah, it comes here. You can see special loads and combinations. Not getting zoomed. Yeah. Just a second. Yeah, even temperature effects come under this. Expansion and contraction, all those are actually loads which are special. They are completely different from the other loads due to heat and cold. The members and elements undergo expansion and contraction, and that comes under special load. Fatigue. In this you can see the accidental loads are due to collisions, explosions, fire. All these comes under accidental loads. And for that we'll be using this code book. We'll be using this in detail later on. So this is just for your reference. So these are the code books which is used for loads and load combinations. The RCC and the steel code books are different. We'll see for RCC now. Yeah, for RCC code books. For RCC code book, the first one comes under the general code book, which is IS 456. It's a very important code book, which we will be using very extensively. So in this you can see the various values like durability and workability of concrete, things like limit state design, working stress design, the processes and formulas used for it. Everything will be given in this code book. You can see that there is workability of concrete, durability of concrete, production of concrete. Everything is given in this code book only. Everything related to concrete is given in this code book. Slab, walls, stairs, footing, each and every part of the building. For the limit state, you can see in this limit state. Each and every part of the building, the load which we should take for every formula, every element, it is given here. In this you can see shear, torsion, deflection. Everything is given in this code book. That is why it's a very important code book. Even in college, we would have used. Everybody would remember how much we use this code book. So we will be seeing this one by one. I think some of you might still have it at home, this code book. This is like I said, I'll just write it down, just basics. For example, the durability and workability of concrete. Everything related to concrete actually. Concrete or limit state design and working stress design. The process and formulas for this will be given. Etc. This is what general code book for concrete IS 456 provides. The second one is for member designing, like member designing. This code book is for SP16. This is actually basically known as a guide to IS 456. This is a guide to IS 456. This will have tables and charts and graphs that we'll be using in reference to IS 456 and for our calculations. Tables, graphs, etc. This is just a guide to IS 456. It's a very small code book. The third one is general detailing. I'll show you these code books just a second. This is SP34. In this, there will be layout, dimensions of all specifications for different paper size. I'll just write down and then show you. Like layouts, dimensions, etc. and all specifications. Specifications for different paper sizes, like A4, A3, B1, B2. There are different paper sizes used for different purposes in detailing. So, or even symbols, which are very important, the common symbols used. All this comes in this code books. Symbols used. I'll show you. This is SP34. Yeah. And this is just, as the name suggests, a handbook on concrete reinforcements and detailing. Yeah. As you can see, structural drawing for detailing, general for foundation, columns, beams, stairs, slabs. For every single part of the building, they have given details. For the diameter, bars in straight length, diameter. Requirements for reinforcing bar. For types of reinforcements, and in that normal size of bar, the composition of steel, and minimum elongation of gauge length. Yeah, this will be coming in our calculations later on. You will understand better. So this is how they give actually. And how a drawing in a paper should be. What are the additional effects we should give in the paper? How we should submit a drawing to a client. This is how they teach. Yeah, see, this is an A1 sheet layout, and this is an A2 sheet layout. Now, like this, for different paper sizes, we'll be getting how the layout should be and how the markings should be. So this is why this handbook is very important. Next comes seismic detailing. Seismic detailing, it's not the same as seismic load code book. Seismic detailing. Yeah, this is IS 13920. IS. Yeah, actually, this involves when a building is done in a ductile design. Ductile design is usually done to withstand seismic load in a more effective way. It's not completely safe, but that design will prevent further damages or failures compared to normal building. So while ductile designing takes place, this detailing, this seismic detailing code book is used for ductile detailing, ductile building detailing. Yeah, this code book is used mainly for that, and for pile foundation.
So basically, seismic detailing codebook is for designing the building in high seismic zones. So for
Yeah,
that, we'll be using this codebook.
I can write down. Just a second, ma'am. Yeah, thank you. High seismic zone. For better safety. And this one is pile foundation. For pile foundations, there's a separate code book especially for pile foundations. That is IS 2911. They are used for pile foundation design, like the name suggests. It will give you ultimate load capacity and different formulas for it. It's just for an example, I'll write. Ultimate load capacity, formulas, everything related to pile foundation is solely found only in this code book. There's no other code book for this. Yeah, design and construction of pile foundation only for this particular purpose. This code book has been designed for cast in situ concrete piles. The various yeah, you can see the commonly used, including the equipment details, this code book will contain for pile foundation. This you can see that they have given a detailed explanation of what are the equipments used for doing a pile foundation and what are the effects a pile foundation will experience, like uplift force or yeah, uplift capacity and friction, drag down force, everything they have given. The calculation part comes later. First, they are just talking about what materials are used, what equipments are used, and what are the effects of those of constructing a pile foundation. What will it experience? All these are given, and then later comes the calculation part. You will be given formulas and how to. You can see that the ultimate end bearing resistance, we how to calculate, there's a formula given which we will be using in our calculation later on. So right now you don't have to know this, it's just for your reference. Yeah. So this is what these are the code books given for only RCC. These 5 code books. Next comes steel. Yeah, in this Excel sheet sharing. Yeah. Now we have discussed IS codes for various loads, IS codes for RCC. I've just zoomed. Yeah. IS codes for RCC. Next comes IS code for steel design. Steel, also there are different types actually. I will just explain. First, I will tell you the 3 sections of steel. Yeah. There's hot rolled steel, hot rolled, cold formed, and welded sections. There are different code books for each of these. So, for hot rolled, what is actually hot rolled? It's nothing but, like the name suggests, when a hot metal liquid is poured, when a hot metal liquid is poured into the required shape, hot liquid is poured into the manufacturing unit. Can be of it is a manufacturing unit, and then we get the molded form. It can be I section. Usually, I section is done in hot rolled steel. Like there's a manufacturing unit where you can find the shape of I, and in this shape of I, we will be pouring hot liquid so that the shape of I is formed, and we get an I section steel beam. Steel beam column, it can be anything. We get an I section. This is how hot rolled steel is formed, and for that purpose there is a different code. This is IS 800. Most common code for steel is IS 800, just like IS 456 for concrete, RCC, and IS 800 is for steel. This is mainly for molded forms. Cold form is a bit different. That is IS 801. IS 801. In this, we take steel plates, and they are bent, actually bent into the shape we desired, into the body we desired, bent into shape we desire, and then that is a final product, like L section or C section. A single plate can be bent like this, but you cannot form an I section with this. It's very difficult because you're just beating a steel plate into the shape we want. So getting an I section is very difficult. But L section and C section can be formed easily with cold formed method. Welded section is the same, actually, same code book as hot rolled IS 800. It's a smaller section. It takes different plates, actually, like the name suggests. The name, it's easy to understand from the name. Takes different plates and they assemble together to form the shape, and it is welded together. Takes different plates, assembled and welded to form required shape. This is known as welded section. Where like you in this also you can form L and C. That is possible. If you take two plates, an L section can be formed, or three plates you can form a C section. It's like they just weld different plates together to form the section. These are the three types, and I will show you the code books for this. Yeah, IS 800. Interpretation. Okay. I think it's this one. Yeah, IS 800. This you can find out in the contents itself. If you see, you will find out what is available, the different materials used, the different design requirement. You can see that there is basis for design, loads and forces on it, load combinations, and slenderness ratio. This is very important while we'll be doing manual calculation. Slenderness ratio, and later on, yeah, this for limit state design, especially for tension members. Usually, steel is tension member, so we'll be designing strength due to yielding, rupture, and for compressive members, compression is also a part because we cannot ignore the compression completely. For that, we'll be to withstand compression, we'll be giving extra details on angles, laced columns, battened columns. Everything will be coming later on. We'll be studying about it. So this is what IS 800 consists. You can see regarding riveting, bolting, welding, different forms of steel connections will be given here. And you also have IS 189. Yeah, I guess that's it. IS 801 is not commonly used, so we won't be using that code book much. We'll be using only IS 800. So these are the different types of code books required. You can see here, general designing is IS 800. Cold form steel is IS 801. There's a You can see that each code book, what they consist of, basic definition is given here. 801, and member property, just like SP16 is a guide to IS 456, SP6 is a guide to IS 800, and then seismic detailing comes under IS 800 section 12. That is what I showed you. Actually, there was an interpretation code book which I opened in the beginning. It is for the ductile designed buildings of steel. Just like this IS 13920, it's for RCC and this is for steel. These are the different types of code books, and we'll be seeing in detail one by one how to use them later on during manual calculation. Now we will proceed to basic load transfer technique. Just a second. Yeah, we have already seen what a load transfer can do actually. We saw a few classes back a gravity based sequence where it goes from slab to beam to column to pedestal and then to footing in a framed structure. Now we will see an exercise based on it. We had already told that we'll be doing an exercise before in case you remember. And because this is known as basic load transfer because we are considering only dead load and live load. We are not considering any other load right now. This is just a basic transfer exercise. When the other loads are considered, we will be considering other loads in the future exercises. As of now, I will just show you an example for basic. We will see the first question. This Excel sheet will be shared to you, so you don't have to worry. This is the question, like calculate the axial load transfer, the ground level of a fixed structure measuring 5 into 4 into 3 slab. This is the slab. This is a structure height, and this is the slab dimension, and slab thickness is given. They have also given the beam size and the column size, and they are given the type of building. And if you remember, we saw in the initial introduction regarding the code book, loads and load combinations. For dead load, I told IS 875 part 1. In that, I even showed you the different types of buildings that will be given. Similarly, they have given a building name, residential load. It's a residential hotel, and in that, the type of room is dining room. So they have given all the measurements, and they are telling us to consider only dead load and live load. So we will see how to do this calculation. Yeah. I'll just write it down. Basic load transfer exercise. Basic transfer exercise. Basic load transfer means dead load and live load only. So in this we saw that the structure was given. I'll just draw it here. Or in this case, I'll draw it here. So there's a slab. And a ground level is given. Ground level. And the measurements of the slabs were already given actually. 5 meter. This was 4. And the height is 3 meter. And slab thickness was 125 mm. If I remember correctly, this was it. And the beam was given as 230. Yeah, beam size is 230 cross 230 and column is 303. Okay. So in terms of meter, if we write, beam is 0.23 into 0.23 and column is 0.3 into 0.3. Yeah, I think I have covered all the values. And you can also write it's a residential building. Residential building, it's a hotel and it's dining room. This is the question. Now we should calculate, due to gravity only axial force gets transferred to the ground. So we have to calculate axial force only in this question. So we will calculate axial force. axial force. So what? Axial force. We should calculate axial force. Before we calculate axial force, we have to take every member and element separately, and we should calculate load, because axial force is the final force which gets transferred to the ground. So before that, we have a lot of work to do. We have a lot of calculation to do. So for first case, we will take a slab to beam transfer. Slab to beam. In this, we should calculate both dead load and live load, and then we should add both together to know the final load. Dead load is nothing but the weight of the member. Dead load is weight of the member. Weight is nothing but volume into unit weight of concrete. Volume of the member. Volume, this one is kilonewton per meter cube unit. Volume into unit weight. Unit weight of the concrete. In this case, slab is made up of concrete, so unit weight of concrete. Sorry, I said kilonewton. That's my mistake. Volume is in meter cube, and then unit weight of concrete. So that comes in kilonewton per meter cube. So in the code book which we saw, there is open IS 875 part 1. Yeah, in this you can see cement, concrete, plain, pre-stressed, reinforced. Slab is under reinforced concrete. So we'll go to page 8 directly. Yeah, this is page 8. You can see cement, concrete, reinforced. I'll just zoom in. Yeah. Cement, concrete, reinforced, and in that they have given different types with 1% steel, with 2% steel, with 5% steel. In technical terms, according to the code book definition, 1% steel is for slab, 2% is for beam, and 3%, 5% is used for column. That is how the code books tell us to use the values. So in this case, it's slab, it's 1% steel. They have given it's 22.75 to 24.20, the unit weight. Yeah. This is in kilonewton, this is in kg. So they have given it so we can commonly see that from slab to column, the value is ranging from 22.75 to 26.5. If you remember, in general, so as to not refer to separate values all the time, in general, even in college, we took a general unit weight of concrete as 25 kilonewton, actually, weight per mass. So we took it as 25 kilonewton per meter cube. That was what, for design purpose, we always took the general unit concrete unit weight as 25 kilonewton per meter cube. This we just took it as a conservative approach actually. So for that purpose, we will, in this case also, we can take as 25 kilonewton per meter cube. So what happens is, for the slab, the volume is 5 meter into 4 meter into the thickness 0.125 into unit weight of concrete. Unit weight, like I said, it's 25 kilonewton per meter square. Sorry. Yeah, unit weight of concrete per meter square. So what happens if it is 25 kilonewton per meter square? The area of the slab in this is 5 by 4. The thickness is not considered in surface area. So it is 5 into 4. So you can actually easily cancel out this 5 by 5 into 4 and this 5 into 4. So basically what is dead load is, it is thickness into the unit weight of concrete. That is known as the dead load or the pressure load in this case. So what we find is thickness into unit weight of concrete only, not considering the area. So in this case it is 0.125 into 25. So that, I think that comes to 3.125 kilonewton per meter square.
Ma'am,
Yeah.
ma'am, can you please explain the calculation one more time, madam?
Yeah, sure. Just a second, I'll close everything. Yeah. So dead load is nothing but volume into unit weight of concrete. We'll be taking the volume of the slab and the unit weight of concrete, because the slab is made up of reinforced concrete. So we will be multiplying it into the entire volume will be multiplied with the unit weight of concrete. So as you can see, I have written the volume as, the volume is nothing but surface area into thickness. So length
Yes, ma'am.
into width into thickness, that is 5 into 4 into 0.125, and into the unit weight of concrete is 25. 25 it is kilonewton per meter square, the area. So you can
Okay.
actually write 25 by the surface area is 5 by 4 for the slab,
Okay,
right?
ma'am.
The surface area is 5 by 4. So the same thing
Yes.
can be calculated as 25 divided by the area of the slab. So this 5 by 4 and this 5 by 4 will definitely get cancelled. This one
Okay.
and this
Okay.
one. So finally what is left is the thickness and the just the weight of the concrete. So that is what I have written here, thickness into the weight of the concrete. So basically pressure load. Hello?
Yeah, yes, ma'am. Got it, ma'am. You're
Yeah.
calculating it for a meter square, per meter square.
Yes, per meter square.
Per
Yes.
meter square. Okay. I
So
thought it is calculated for an entire area. That's why I got confused,
it's
madam.
for
Now
the
it's clear.
entire
Thank
area,
you.
the area is cancelled out. So basically, it's this thickness into the weight of the concrete, and that is known
Okay.
as the dead load or the pressure load in this case.
You
Okay.
I,
wrote this
Next step
in
is
terms of,
multiplying into total amount of area, no, ma'am.
yes, exactly.
Oh, okay. Thank you, ma'am. Thank you.
Yeah. I think Madhumanti madam was telling something. Hello?
yes, madam. Unit weight of concrete is kilonewton per meter cube. There was some confusion for
So
somebody.
I wrote meter cube. Okay, I changed it. Okay, yeah.
Yeah,
Kilonewton.
that okay, madam. Yes.
Yeah, that
So
was
here we are calculating the dead load of the slab, right? Okay.
yes. Only
Okay,
the
madam.
slab. So
Yes,
when
madam.
we, yeah. Is this clear now? For this area only we are calculating the dead load for the slab area. So per meter square if you take, you will be getting 3.125 kilonewton per meter square. This will be the dead load. But for live load it's a bit different. For we'll be going to IS 875 part 2. I'll finish it with live load so that I know the time is up, but just a second. Live load. Live load we can go to IS 875 part 2.
Ma'am, just a second.
Yeah.
In last slide, madam, we have been calculating the dead load per meter square. The final value should come on 3.125 kilonewton per meter square only, no, ma'am.
Yes, I have written that only. See this one?
Okay, okay, okay. No, ma'am. Sorry for interruption.
Okay, okay. It's 0.125 into 25, so it comes to 3.125 kilonewton per meter square. For live load, we already saw what type of building is given, and if you just substitute the value for the type of building, you will get live load. Live load, there is no calculation required. So in this we saw, yeah, in this, just a second. Yeah, in this we saw that it's a residential building. The question has the term residential building, and it also has the term hotel, and in hotel they have given specifically that it's a dining room. So dining room is the fifth one, dining room. So you can see that the live load is 4. Yeah, uniformly distributed load is kilonewton per meter cube. So sorry, meter square. And yeah, they have given kilonewton per meter square and it's 4. So we can just directly take the value because the dead load has already been calculated in kilonewton per meter square. So the live load will also be 4 kilonewton per meter square. So the total dead load plus live load will amount to 7.125 kilonewton per meter square. This is the dead load plus slab load. Total pressure above the slab is 7.125 kilonewton per meter square. I hope it's clear until this point. We'll be calculating further, but since the time is up, I'll be continuing on Tuesday. I hope everything is clear until now. We will see in the next class how to calculate through slab to beam. This is just above the slab. The load is just above the slab.
Madam, here you are not considering the finishing load.
No, the
Low
finishing
fin-
load is not. This is just basic load transfer. So we are not considering the extra load like finishing loads.
Finishing
Just
or the
basic.
partition load,
Yeah.
nothing.
That won't be coming under basic load. That will
Okay.
be coming under normal load calculation.
Okay,
This is
fine.
just basic.
Fine.
Yeah.
So here we are seeing only the basic load transfer techniques, sir. So we are just explaining how the loads are getting transferred. So those floor finish load, everything will be considered while doing the slab design. Okay, sir.
I
So
think
any doubts? Anybody have any other doubts?
this exercise is being done only for understanding, so that future calculations will be easy. Just to have a basic understanding, we are doing this exercise. So right now we have taught about the slab, and next we'll continue from slab to beam and beam to column. That will be done in the next class. We'll meet you soon. If you have any doubts, you can ask or put it in the chat box. Okay. Okay, then have a good weekend. See you on Tuesday. Thank you.
Sure,
Thank
ma'am.
you.
Thank you, ma'am.
Thank you.